Just an information before we begin. Things are moving so fast that I haven't finished editing this video before some things already changed. So you will see a few jump cuts between new me and old me talking about the project. And let's begin. Hello ladies, gentlemen and small fairy creatures from Alpha Centauri. Welcome to a little update video on the Garden Space program. Water Filler 2 is now nearing the end of its life. I'm gonna shut it down in a couple of days or today, depending on the weather. It has performed very well for what it is. It was a complete mission success. The thing here is I did make some questionable design decisions, and also, and that's the main reason, the battery that the thing uses is a 6-volt motorcycle starter battery. So it really doesn't like deep discharge cycles, which given its size is inevitable. I'm now at the point that I can't run the Raspberry Pi with the camera anymore. Maybe if the sun shines perfectly on the solar panel, but I doubt it, because usually the Raspberry Pi uses a bit more power than the solar panel provides, so the idea was to run it only every few days or so. Well, it did all that it was designed to do. We tested the whole system, it just works. Not as long as I hoped, but frankly it was working better than my worst case scenario, so there's that. And I'm now in the process of designing the new or the next mission. Another problem I knew would happen was with the rain sensor of the water filler probe. It's just a water level sensor with exposed copper traces that pass DC current, so it's gonna corrode, and it has. Now it says permanently that there is water in the sensor, even if it isn't. But it was a good proof of concept, and it didn't cost me anything extra because it was included in one of those Arduino sets. I will redesign this and see what's available for cheap, and we'll see about that. But it was a good proof of concept, and in future probes something like this will let me automate stuff depending on the weather. I haven't decided on the next science payload for the future probe, which doesn't even have a name yet. But I'm currently working on the engineering side, so making the platform so we have enough power, we have stable power, and also I'm gonna make sure I disable all the power LEDs and stuff, so we don't get internal reflection of LEDs that just waste power and mess up the cameras. Because yeah, on Water Filler 2 I was trying to photograph stars, but the internal reflections pretty much prevented it. I had some success using only the blue channel, but yeah, nothing major. And when I say new project, I really mean new projects, plural, because I'm gonna split the whole solar power system into its own project and run whatever I'm doing for a probe basically off that. But it's the new solar thing will be a permanent or semi-permanent installation, just because of the cost, the size, and how I have to install it, make it more robust and make sure it doesn't fly off on the next storm. I've already ordered the new solar power system, so the solar panel, the charge controller, the solar battery. It's now a deep cycle battery. I've got a much bigger solar panel and a much better charge controller. So the original water filler used this solar panel, which is basically 12 volts at about 300 milliamperes if the sun shines directly at right angle on the solar panel. It's really not enough for many situations. Water filler 2, which is basically the improved version of the original water filler, used a solar panel that was about 10-11 volts at nearly 1 ampere, so that gave us a lot more charge. But I used the same type of battery, which, as I said, is a 6 volt motorcycle battery that really hates deep discharge cycles, and we had a week of bad weather and they pretty much killed the battery. And also it was only 4.5 amp hours, so it's like what is it, 27 watt hours, something like that. The new power system for the next probe will have 100 watt 12 volt solar panel. It's a bit more than 12 volts. It's like 18 volts, but usable is 12 volts, something like that. It's solar. It's all a bit complicated, and the original water filler and the water filler 2 used a PWM controller to charge. So it just turned on and off the solar panel to battery thingamajig. The new charge controller I have on order uses maximum power point tracking, which basically enhances the way it pulls power out of the solar panel and puts it in the battery. So you get 20-25% improvement. So combined with the bigger solar panel, that really means that just by changing the charge controller from PWM that pulls with modulation to MPPT, we got an efficiency increase about 20 watts or something, which means more or less that the improvement in the better charge controller manages to pull more out of the same solar panel than water filler has now total. So we get like 10-20 watts extra power, and we only have 10 watts on water filler, so that I think is a good investment. And I also got a much larger battery. It's a 12 volt battery. It's also on order, so it will arrive in a few weeks. And it's 12-volt battery, which lead acid battery, so it's 12-14 volts, but you calculate with 12 volts, and it has 100 amp hours. So the battery alone has a capacity about 44 times larger than what you have in water filler. That will really allow us to run science during the night, make photographic campaigns, make other science experiments. I'm not sure yet what I'm gonna do, but I wanted to do the engineering first and then see what we can use that power for. The other thing is the next probe, again I don't have a name for it yet, will be designed to run at least 1 year. The battery itself has about 600 deep discharge cycles before it starts to fail or starts to lose much capacity, so that should in theory give us 2 years of operation on battery alone. I'm also redesigning the whole power control system. On water filler 2 I had set up the voltage regulators, so they're always on and always using power and stuff, and they're always connected to the charge controller, so in deep discharge situations everything cuts out. But when we have power, we always using power even for stuff that's not on. I'm gonna completely redo or redesign this stuff. The main power controller, which is also the main communication modem, will be something like this. This is Arduino Pro Mini that I used last year for the missions. I had some troubles with it, but in the course of implementing water filler I found out what the problem is with the voltage regulation mostly, and now we're gonna use some external, I can't show it, it's hardwired, but we're gonna use some external voltage regulator that can handle a lot more power, and this will run the RF24 modem and the mostly the power configuration relays, which are, do I have some of those here? Yes, I do. I'm mostly using this kind of relay. I know it doesn't show well on camera, but those are bistable relays. So wherever you set it, even if you took away power, it will stay on that setting, which is very important, because sooner or later we will run in situations where the Arduino reboots or power temporarily fails, whatever, and these keep the configuration. The thing here is I want to run the Arduino either directly from the battery or from the solar panels, which will be switched by one of these relays. The idea here is, especially in winter, when there might be snow on the solar panels, I can disable the power to everything and tell the Arduino, the power controller and modem, basically to run only on the solar panels, which means the charge controller is gonna recharge the battery, but we are not gonna use any of it. So if there's snow on the thing, on the solar panel, we just don't use any power of the battery. We don't run into a situation where we very deeply discharge the battery, which will prolong lifetime. And when the snow finally melts, power will come back to the Arduino and we can continue operation. I also have the idea of mounting panels like these, but possibly with more cells, vertically in the direction of the winter sun, and with a couple of diodes you can just say, okay, use any of the solar power available and it doesn't short out the panels and stuff. Basically wherever power is, use that just to power the Arduino and get power. Let me remote control this thing even if it doesn't charge the battery. And since this is a operation that's planned for a year or more, and we got summer, we got winter, I have to look into really sort of making sure the battery doesn't get too cold and we can recharge it. I'm not sure how I'm gonna do that, but most likely I will use the water feeler solar panel as basically another extra solar panel, also mounted much steeper than the standard solar panel I will have on the probe, because I don't want to mount a big solar panel in a situation where the wind can just flip over the probe. But we will probably use the 10 watt panel for also on controlled by relay, to run optional heaters under the main panel and in the battery compartment, so we can basically try to melt the snow and keep the battery at a temperature where it can charge. I'll have to experiment on that, but that's my basic idea, so have some independent power systems that will also let me run basic diagnostics and stuff even if the main solar system is offline for some reason. And I'm also I'm gonna use a Raspberry Pi or more. I'm not sure yet, depends on how I can set up cameras and stuff and what science experiments I'm gonna do. Treat them as more or less science and engineering instruments. And for a long time I really want a way to set this all up so I can switch everything to solar only mode. So okay, it will only run when the sun is up, but we should have enough power on the solar panel for most of the day because it's so much larger and more powerful, and cut out the battery stuff completely so we can get a few more months or years out of the thing. As I said, I haven't decided on the science experiments and the science goals of the new probe yet. I'm gonna do the engineering work first and see that all works. And One thing I'm also gonna do, I will have a camera or two, not sure yet. There is some adapter for the Raspberry Pi to run multiple cameras. Not sure if I can get my hands on it and if it works, but that would let me run multiple cameras from one Raspberry Pi, which would decrease the engineering requirements a lot. As with water feeler, the next probe will run the same RF24 communication network because it just has proved very reliable. But the one thing is, the more reliable you make it and the more flexible you make it, the less bandwidth you have with all the checksums and routing information and stuff. It just limits the amount of data you can put in per packet, which is only 16 bytes of payload for the standard RF24 network I'm using. And also I'm quite limited at the bandwidth because the Raspberry Pi routes through the Arduino, and that's limited by serial speed and all that kind of stuff, and round trip times and things. So on the next probe, at least the Arduino that does the imaging will have its own RF24 adapter, which will work on a different frequency, on a different part of the spectrum, and it will not include routing information. It will work at the highest bandwidth, the highest connection speed, so to say, because that's a bit less reliable, but has like 4 or 5 or 10 times the bandwidth, which will allow me to transfer data much more quickly. It won't be a complete protocol for configuring stuff and that thing. That will always be handled by the Arduino. The Raspberry Pi has a data channel, or will have a data channel, for up and downloading mass data, big files, very fast. On the Raspberry Pi with the cameras, I'm also gonna include ham radio, so amateur radio, slow scan television, transmit only of course. It's a low resolution, it's analog, it's gonna be a bit image noise added, but it will allow me to experiment with the technology and also download previews of images taken very quickly. I've ordered already the bandpass filters because I'm using just an GPIO pin to generate this. There is software for that, but it's very noisy, and the bandpass filter just makes the noise go away mostly, so we are legal. I have a ham radio license and I don't want to lose it, so I have to take every precaution I can. I also ordered the fitting antenna for my ham radio set. I bought on eBay 2 years ago. Haven't really used it yet, but I had a test set up, so I know I can transmit slow scan television and get it decoded. What I really want to go for with at least the camera setups, to have multiple cameras on the Raspberry Pi for different cameras for different things. One again will be the panoramic camera that just looks out of the side of the probe, and probably gonna go with the vertical image again. Might even use the same camera, I'm not sure yet. Probably not. I'm gonna probably switch to a Raspberry Pi version 2 camera for that. I also want a no IR filter camera, so with the blue gel thingamajig that really shows plant life stuff. And I want to have at least one camera set up to image the sky. Depending on the kind of science experiments I'm gonna include, and I'm gonna include hopefully quite a lot of them, I want to have at least one internal camera in the thing, in the box basically, to image the experiments that need visuals or to confirm they're working. I'm not sure yet, as I said, what experiments I'm gonna do. I might also try to build a UV camera, not the classic, you know, CCD chip and then scrape off the filters and fix the lenses, but what I'm probably gonna do, if I can get it to work, which I still haven't tested, have sort of a 2D scanner thing with a UV sensitive, not LED, a UV sensor, and have basically a box built that projects an outside image onto the plane and then scan it pixel by pixel. Not sure yet, but that should work. The Arduino also is going to have a real-time clock module added, so we can do timed stuff. And also when we power on the Raspberry Pi, it can get time from the Arduino. But the Arduino otherwise is really gonna be the main control modem and power control. So it's gonna handle the low level stuff, and maybe, because that only uses a couple of pins, the usual DHT, the digital humidity and temperature sensor, so we get some sort of overview. The solar charge controller also seems to have, at least if I read the eBay listing correctly and did my googling well enough, has a serial port which we can read out the state of charge and if we get solar power, that kind of stuff. So we should get a much better sense of our power levels and charge levels and that kind of stuff. Well, that's it for the update for now. As you can see, I still haven't worked out all the engineering details, but this is just to let you know my current plans and give you an overview of what we're going to do in the future with the Garden Space program. It's still very much everything in the air, but I ordered the main parts of the power system. They should arrive in a couple of weeks, and I can start testing and seeing where the main problems are, because it's electronics, there are always problems. Okay, and here we are with the new solar panel. It's here. Damn, this time traveling is a bit confusing, but stay with me. And this is about the size of the old solar panel from Waterfield. Although Waterfield has a lot less solar cells. This is a failed project. I'm now using it as a work desk surface because it just doesn't work. Made some soldering errors. But yeah, it's quite a bit larger, much better made, and it's a 100-watt solar panel. We also got the new charge controller, which is maximum power point tracking instead of PWM of the old small one. And it comes with this is a control interface thingy. I hope to decode the protocol. It has RJ45 connectors, but it actually has a serial bus, and I hope to decode the serial bus protocol, so instead of using this in my final build, I can use my Arduino to get charge information and things like that. I will keep you updated, and also if you have good ideas for science experiments we can do with limited power and my limited budget, let me know, because you know, you can just tell me what you would find interesting. I'm open to any suggestions. And if you have a science instrument that you actually have built for using with an Arduino or a Raspberry Pi, and you want to have me included in the long-term science thingamajig in my GardenSpace program, just let me know in the comments, and then we probably can work it out that you just send me the thing, I put it on the probe, and you get real-time access to all the data, and I'll do all the running for you. I build it into the thing, you don't have to worry about it. And I can run it for you, can give you real-time access to the data and that kind of stuff. So it's basically fly your instrument on my space missions thingamajig. Okay, I think that's all. If you like this video, then like and subscribe as usual, and I will see you next time. Bye!